Okay, so this is going to be for Tuesday, October 6th, and we are going to be continuing with the interest problems like we have been doing, except now we're going to be comparing them, which just means, and we're going to look at two different scenarios, and we want to figure out typically either what the difference is between the two, so ultimately we'd be subtracting the two answers, or just deciding which one is cheaper. That's one of the options. So we're either going to be doing one of those two things. But we're still going to have to use our formulas for simple interest. I equals PRT, or P times R times T, which just counts the interest. So if we wanted the total, we would have to add the P. Compound interest already calculates the total. Balance, in other words, for total amount. Remember, your R for rate is divided by 100. We're using the little arrow key sign on the calculator to get our exponent up there. Loans. Borrowing money is bad because you really end up having to pay back more than what you have borrowed. Savings, retirement funds, saving money for the future is good. Okay. So I know Coach Elkins goes through these on the notes, and I'm really just here to go over the homework to kind of get you started on those. Sometimes that helps. So we're going to go ahead and look at the comparing interest problems. Up at the top, I'm going to go ahead and write my formulas down so they're close and easy to see. And it helps to separate the two also, so you don't accidentally use the wrong formula. That would be sad. Okay, so let's look at number one. Two customers took out loans from a bank. Henry took out a 4-year loan, so there's my time, for $6,000 and paid 4.2 annual simple interest, so PRT. And that's my rate. I'm going to go ahead and change that rate. I'm going to divide it by 100. So instead of 4.2, I'm actually going to be using 0.042. Okay, so let's look at the second person. Ingrid took out a 6-year loan for $6,000 also, but she is paying a 3.9% annual simple interest rate. So we're using the same formula on both. That's very good. And I'm going to go ahead and divide 3.9 by 100 so I don't forget to do that. So that's actually going to be 0.039. And the question is asking me, what is the difference, which means subtract, between the amounts of interest Harry and Ingrid paid for their loans? So what we're going to do is we're just going to plug these into my formula. So I'm going to write kind of small, but I'm going to put 6,000 times the rate, 0.042, times the time, which was 4. So 6,000 times 0.042 times 4. Okay, so Henry is paying $1,008 in interest. Ingrid, let's go ahead and multiply her. So she's got 6,000, I guess I should write it out, huh? 6,000 times her rate was 0.039, and her year amount for the loan was 6. Okay, so 6,000 times 0.039 times 6, 1404. Okay, so I've got Ingrid and I've got Harry. So now I'm going to subtract these two numbers. I already have 1404 in my calculator, so I'm just going to hit minus. So it takes that number and it's going to subtract what I put in next, which is Henry's 1008, and I get 396 when I subtract those two, which is C. Just remember on ones like this, so if you're using the same P, you just want to make sure that you're changing all of these. You're dividing all of these by 100. If these were all the same rate, like if these were the same numbers, then you would just look for the shortest amount of time. But since these are all different, you're going to have to actually use the whole formula. So 2,500, sorry, times 0.047 times 18. You can put 18 in there, or you can divide that by 12. Either way. Number 3. Same thing. Tom's mother's planning to borrow $20,000, so that's your principal. And then she's got 2 different options. So company 1 offers an interest rate of 7.25. Company 2 offers 6.5. So let's go ahead and turn those into decimal. 6.25 divided by 100. Okay, so that's 0.0725. 6.5 divided by 100. 0.065. And then both loan options involve simple interest, so that tells us what formula we're going to use. It needs to be repaid in exactly 3 years. So how much more will Tom's mother pay in interest if she chooses to borrow the money from company 1? How much more tells us we're going to subtract. So we need to do 20,000. We'll do company 1 first, times 3. Okay, so that's company 1. Company 2, same principal amount, times, where is that? Company 2, 0.065 times 3. Okay, so when we multiply all 3 of those together, multiply all 3 of those together, and we're going to subtract because you want to see how much more she's going to pay. Number 4. Same thing, the only thing that's different is the years. So your 2 separate problems, principal 5-year or a 3-year. And the rate is 7.25. So 7.25 divided by 100 is actually 0.0725. So when you work them out, times rate, so 0.0725 times 5, and then the same thing with the same rate, but a shorter loan amount. And then same thing, how much more? We're going to subtract. So you multiply those 3, subtract. Okay, number 5. Mr. Wilkins deposited $2,500 into a new bank account. The bank pays 6.5% interest compounded annually. Okay, so compounded annually tells us we're going to be using the compound interest formula. Mr. Wilkins made no additional deposits or withdrawals. Which amount is closest to the balance of the account at the end of 2 years? The balance is the same as total. So whenever we get this, after you put this in the calculator, that's it, you're done. That is your total. No subtracting or adding or anything weird. And here's my time, I forgot to do that. Okay, so I'm going to use that formula. I'm going to rewrite it. I like to write them out and then write it underneath with my numbers for this problem. 1 plus the rate. It's not 6.5. It is 0.065. And then the time, 2. So just a refresher on how that looks in the calculator. We've got 2,500, open parentheses, 1 plus 0.065, close parentheses, and then your little arrow under the clear button, and then we're going to put 2. So 28, 35, 56. 6 is kind of the same. That's a principal, except we're looking for simple interest. At the end of 4 years, there's your time. The balance of the account was $6,500. What is the annual interest rate? Okay, this is not the same, just kidding. Mr. Flores opened an account with a deposit. Okay, so I'm going to write the formula down for simple interest. That's what it told me to find. I equals PRT. So I'm going to plug in all the numbers that I do know. So it said at the end of 4 years, the balance of the account was $6,500. Okay, remember balance means total. So they've added what it originally had, what was deposited, plus the interest. So what I need to do is take this 6,500 and subtract the 5,000 to figure out what's going to go here for the I. What's the interest? So 6,500 minus 5,000, 1,500. So 1,500 is my interest. Since this is my total, that's not my interest, that was my total. So for the interest, 1,500 equals the principal amount of 5,000 times something, we don't know, that's what it's asking us, times 4. So here's the thing, we've got these 3 and one of those we don't know. So I'm going to combine what we do know over here, the 5,000 and the 400. So 5,000 times 4, not 400, holy cow. And I get 20,000. So by combining these two, 20,000 times what's left, which was just R, equals 1,500. So now it's just a one-step equation. 20,000 R equals 1,500. So we want to get rid of the 20,000. And since that's multiplication, the opposite would be to divide. Which seems crazy, but...
Well, I know it's a little late on a Monday afternoon, but if you don't rise for the pledges.
That's a problem. 0.075. Which is what we would use as a decimal. So think about which one of those would match if we turned it into a percent. This is compound interest rate, PT, principal rate, but divide that by 100. And this is simple, so that's the PRT. And there's your time right there. So that one wasn't really comparing.
Metal Management
Oh my gosh, that was a very fast
Monday here at China Spring Middle School. We've got some volleyball